So, thank you for joining me today. We covered how to design isolated footing. I will focus today only on isolated footing. We have one column supported by one footing. The main target is what are the dimensions of this footing, length, width, and what is the safe thickness for this footing. And then how much steel reinforcement needed in both directions, this direction and this direction. Most of the time, if your column is square, your footing will be square. So the dimension or the shape of the footing will equivalent to the shape of the column. That makes sense? We covered how to design isolated footing with hand. We have few steps. Step number one, I need to put the value of dead load, the value of live load, adding them together without any factor. Step number two, I will add dead after multiplying it by 1.2, live by 1.6. Step number three, I will assume my thickness. We can assume a thickness in the range of 2 feet, 24 inch, or something in this range. I will figure out the value of Q net, which equals the value of Q allowable, which is the bearing capacity. This is the bearing capacity of the soil. And I will subtract from this bearing capacity the thickness of the footing times gamma concrete. I will subtract also the gamma of soil, which is filling the soil, by the thickness of soil. HS times gamma S. S means soil. Once you get the value of Q net and you have the summation of the dead and the live without factor, if you divide it, the dead and the live without factor by the Q net, you can figure out the area required for your footing. Then this area can be converted to square by taking the square root of this area, or can be converted to a rectangular area. You can assume one dimension and you can figure out the second dimension. Keep in your mind, we assumed the thickness of the footing. I need to make sure this assumed thickness is safe against two-way shear, which is called punch. So I have to figure out the value of Q ultimate and the value of B naught and the value of F ultimate 2. Then I will check the required depth to make sure the footing is safe against punch. Hopefully, this depth will be smaller than or equal the assumed one. Keep in your mind, we assumed one before. I did not assume that the depth, but I assumed that the thickness. If you subtract this thickness minus concrete cover, you can find out the assumed depth. Hopefully, the required one will be smaller than or at least equal the assumed one. Also, I will check against the one-way shear by figuring out the value of L prime, the value of the ultimate one, and then what is the required depth, and hopefully it will be smaller than or equal the assumed one. And we solve it example. So once your depth is safe, I will start to figure out what is the applied moment at the edge of the column. And this moment will be used to figure out this value. And from the table, I can figure out the value of rho. Make sure this rho is greater than or at least equal the value of rho minimum. Then the value of rho will be used to figure out the area steel. This area steel will be converted to how many rebars and what is the size of your rebars. And we solved this example before to show up the steps. Today, I will solve this example one more time, but using RISA Foundation. We have a software called RISA Foundation. How to download this product? You need to open the Google and search for RISA products. And products here. Then go down. We covered RISA floor before. RISA connection will be covered in the steel design course. We have here RISA Foundation. Go ahead and try this product. You need to create an account. If you have already account, go ahead and sign in. Put your information number. And you have the products here, RISA Foundation. There you go. And then you can add them, download them. You don't need to buy. They will give you 10 days trial, free trials, just trials. Go for foundation, download, set up it, and you will have 10 days to use RISA Foundation for free. So I downloaded the software and I set up the software on my computer. This is the icon. If you remember, this one was for RISA floor. We covered this before. This one for foundation. I will double click on it and I'm gonna use launch demo. Okay. I will not use any of these, so I will close this window. If you don't like these grids, you can hide them from view drawing grid if you want, but I will keep them. So first of all, I will define a joint or point where you need to define your footing. So from insert point, I will locate enter. I will locate this point at 0 and 0. First, we are going to design one footing only. So from insert, I will put one point. This point can be anywhere, 0, 0, 20, 20, 10, 10. It's up to you. I don't care where is this point. I can locate it anywhere. Why I defined a point? Because from insert loads, I need to define point loads. We have a value for the dead load equal to 100 kb. So for dead load, I will define here 200 kb positive direction. Positive direction. So all positive Y loads are downward. So don't be confused. Apply, then I can apply my force here. One more time, insert, loads, point load. I can define the value of live load. It will be 160. Positive, because all positive Y loads are downward. I can define it here. From the right-hand side list, we have here footing definitions and the soil definitions. If you cannot find this list, you can find them from a spreadsheet. We have here soil definition. In this window, I'm going to define the allowable bearing capacity. If you look here, the bearing capacity equal 5,000 PSF, means pound per square feet. However, the value in this program should be in KSF, means kb per square feet. So the value 5,000 will be 5 KSF, means kb per square feet. So your value here will be 5. That makes sense? Also, I will define footing definitions. If you cannot find footing definitions from here, you can find it from spreadsheet, footing definitions. In this one, we have general definitions. I will define the minimum row of steel reinforcement, the maximum row of steel reinforcement. What is the minimum reinforcement? What is the maximum reinforcement? Also, I will define the material. We have different materials. Concrete with compressive strength equals 3000 psi, normal weight. NW means normal weight concrete. We have lightweight, LW. Since the compressive strength of concrete here is 3000 psi normal weight, I'm going to use here 3000 normal weight. That makes sense? So, from geometry, I will define what is the maximum length of your footing, what is the minimum length of your footing, what is the maximum width of your footing, what is the minimum width of your footing, what is the increment of design, what is the maximum thickness, what is the minimum thickness, what is the thickness increment. If you would like your thickness to be even number, I have to define the thickness increment to be 2 inch. So he will start with the minimum, 12. Then he will increase to be 14, 16, 18, 20, 22, 24 maximum until the program can find the safe thickness. Also, the last one, you can force square footing. If you check this one, you can ask the program to design your footing to be square. If you did not check this box, the program will design your footing to be rectangle. Does that make sense? Let's try it. Square. Okay. Then I will draw my footing from this little icon. Footing, apply, then I will draw my footing. We are ready. We are ready. But I need to check the load combination. I solved it, but you can check the load combination or from this little icon or from spreadsheet load combination to make sure your dead multiplied by 1.2 and your life multiplied by 1.6. If you would like to solve, you can click this icon so the program will solve. Once the program solves, you can find here footing results. Footing results. Or from results, you can find footing results. Here is the design of your footing. The length will be 9 feet, the width will be 9 feet, the thickness will be 24 inch. If you would like to see more details, you can detail report for current item. This is the design. This is the dimension of your footing. This is the thickness. And you can go down. This is the steel reinforcement. We need number 6. Rebars number 6 every 10 inch in this direction, and rebar number 6 every 10 inch on the other direction. That makes sense? So I need 11 rebars number 6 in X direction and 11 rebars number 6 in the other direction. The total area still required 4.86. And the program will check of the soil bearing capacity, will check for the strength and the check for the shear and the bunching. We have bunching check and we have shear check. If there is something, the program will tell you we have issue. Does that make sense? Looks like we have issue with the bunch. Looks like we have issue with the shear, because this factor must be smaller than 1. And this color with red means you have issue with the bunch. To solve this issue, unfortunately, you put limit for the footing to be 24 inch. So I have to go back and define footing definition. the maximum thickness can be until 36. That makes sense? So let's try one more time. Solve and footing results. The maximum thickness I need 28. That makes sense. If you go here, this factor became smaller than 1 with blue color, not red color. That means we are safe. That makes sense? So the final design of your footing will be 9 by 9, and the thickness I'm gonna use will be 28 inch. Does that make sense? If you would like, I can show you isometric. I can show you the extrude value view, render view, so you can see your footing and the column and the applied